1. Physicists detect largest ever merger of two black holes equal in size to 240 suns. 2. Unveiled, most massive black hole merger ever detected. 3. Massive black hole merger detected, gravitational wave discovery. 1. Physicists detect largest ever merger of two black holes equal in size to 240 suns. Imagine a cosmic collision so massive that it creates a black hole equal in size to a staggering 240 suns. This is precisely what physicists have recently detected, and it's sending shockwaves through the scientific community. But here's where it gets controversial. Black holes of this enormity shouldn't exist according to our current understanding of astrophysics. The merger of two gigantic black holes, each with a mass 100 and 140 times that of our Sun, has left experts reeling and forced them to rethink their models of the universe. This extraordinary event, designated GW231123, was spotted on November 23, 2023, by the Gravitational Wave Detector Network LIGO-Virgo-KAGRA, LVK, and it's the largest ever merger of two black holes detected to date. The implications are profound, and physicists are eager to unravel the mysteries hidden within this cosmic phenomenon. So, let's dive into the fascinating world of black holes and explore what this discovery means for our understanding of the universe. Black holes are regions of space where gravity is so intense that not even light can escape, and supermassive black holes are the largest and most destructive of them all. They reside at the centers of galaxies, including our own Milky Way, and their event horizons mark the point of no return, beyond which anything that enters cannot escape. The recent merger created a black hole so massive that it challenges our current understanding of black hole formation. As Mark Hannam, a physicist at Cardiff University, noted, black holes this massive are forbidden through standard stellar evolution models. This discovery has sparked a new wave of research, with scientists eager to refine their analysis and improve stellar evolution models. The LIGO-Virgo-KAGRA collaboration has been at the forefront of gravitational wave detection, and their work has opened up new frontiers in our understanding of the universe. But what exactly are gravitational waves? First theorized by Albert Einstein in 1916, they are ripples in the fabric of spacetime created by powerful cosmic events, such as the merging of supermassive black holes. The detection of gravitational waves has allowed scientists to study these events in unprecedented detail, and the recent discovery has marked a landmark achievement in gravitational wave science. As Amit Singh Ubhi, a research fellow at the University of Birmingham, said, "It opens a new frontier in our understanding of black hole formation and underlines the urge to accelerate innovation towards the next generation of gravitational wave detectors." The discovery of this massive black hole merger raises many questions, and scientists are eager to explore the implications. For instance, could the two black holes have formed through earlier mergers of smaller black holes? The answer to this question could revolutionize our understanding of black hole formation and the evolution of the universe. As Gregorio Carullo, a Birmingham professor, noted, it will take years for the community to fully unravel this intricate signal pattern and all its implications. There are exciting times ahead. So, what do you think? Are black holes the most fascinating objects in the universe, or are they a reminder of the awe-inspiring power of cosmic forces? Share your thoughts in the comments below, and let's explore the mysteries of the universe together. And this is the part most people miss: the detection of gravitational waves is not just a scientific curiosity, it has the potential to reveal the secrets of the universe and challenge our current understanding of the cosmos. But here's the question: are we ready to face the implications of what we might discover? The universe is full of mysteries, and this recent discovery is just the beginning of a new era of exploration and discovery. As we continue to push the boundaries of human knowledge, we may uncover secrets that challenge our understanding of the universe and our place within it. So, stay tuned, and let's embark on this journey of discovery together. 2. Unveiled, most massive black hole merger ever detected. In a groundbreaking discovery, scientists have identified the most colossal merger of black holes ever recorded, an event that has sent shockwaves through our understanding of the universe. This extraordinary collision, detected through the ripples in spacetime known as gravitational waves, involves black holes of such immense size that they could potentially upend existing cosmic models. The monumental merger was captured by the LIGO-Virgo-KAGRA (LVK) Gravitational Wave Detector Network on November 23, 2023, during its fourth observational run. This network comprises 3 highly sensitive laser interferometers located in the United States, Italy, and Japan, working in unison to detect these elusive signals. The event, labeled GW231123, involved 2 progenitor black holes with masses of 100 and 140 times that of our Sun. When these titans merged, they formed a daughter black hole weighing in at an astonishing 225 solar masses. The energy released during this merger was so immense that it generated gravitational waves that rippled outward from the cataclysmic event. Before the detection of GW231123, the record for the most massive black hole formed from a merger was held by a black hole with a mass of 140 solar masses, identified in 2021 as GW190521. Mark Hannam, a researcher from Cardiff University and part of the LVK collaboration, stated, "This is the most massive black hole binary we've observed through gravitational waves, and it presents a real challenge to our understanding of black hole formation." Black holes of this magnitude are typically considered impossible according to standard stellar evolution models. Hannam suggested that one possible explanation for the formation of these massive black holes is that they originated from earlier mergers of smaller black holes, hinting at a complex history of cosmic collisions. What makes GW231123 particularly fascinating is not just the sheer mass of the black holes involved, but also the indication that at least one of them was spinning at an incredibly high rate, potentially at the very limits of what the laws of physics permit. Charlie Hoy, a member of the LVK team from the University of Portsmouth, remarked, "The black holes appear to be spinning very rapidly, near the limit allowed by Einstein's theory of general relativity." This complicates the modeling and interpretation of the signal, making it an excellent case study for advancing our theoretical tools. LIGO, the Laser Interferometer Gravitational Wave Observatory, has a storied history of breaking records. In 2015, its twin detectors in Livingston, Louisiana, and Hanford, Washington, made the first-ever detection of gravitational waves, a momentous achievement that coincided with the centenary of Einstein's prediction of their existence in his 1915 theory of general relativity. The initial signal, known as GW150914, resulted from the merger of black holes that produced a daughter black hole with a mass approximately 62 times that of the Sun. Since that historic moment, LIGO has been joined by the Virgo and KAGRA detectors, leading to the detection of over 300 black hole mergers. Remarkably, more than 200 of these detections occurred during the current observational run, showcasing the rapid advancements in gravitational wave detection technology. However, the extraordinary mass and rapid spin of the black holes involved in GW231123 have pushed the boundaries of what we thought was possible, both in terms of detection capabilities and theoretical models. Sophie Binney, a researcher at the California Institute of Technology, Caltech, and a member of the LVK team, stated, "This event pushes our instrumentation and data analysis capabilities to the edge of what's currently possible." It's a powerful example of how much we can learn from gravitational wave astronomy, and how much more there is to uncover. Unlocking the full potential of this signal and others detected by LVK until the end of its fourth observational run in January 2024 will require significant advancements in analysis and interpretation methods. Gregorio Carullo, a member of the LVK team from the University of Birmingham, noted, "It will take years for the community to fully unravel this intricate signal pattern and all its implications." While the most likely explanation remains a black hole merger, more complex scenarios could hold the key to understanding its unexpected features. Exciting times lie ahead. The findings related to GW231123 were presented at the 24th International Conference on General Relativity and Gravitation, GR24, and the 16th Eduardo Amoldi Conference on Gravitational Waves in Glasgow, Scotland, on July 14. Join our space forums to continue the conversation about the latest missions, night sky events, and more. If you have any news tips, corrections, or comments, feel free to reach out at community@space.com. Robert Lee is a science journalist based in the UK, with articles featured in publications such as Physics World, New Scientist, and Astronomy magazine. He also writes about science communication for Elsevier and the European Journal of Physics. Rob holds a Bachelor of Science degree in Physics and Astronomy from the Open University in the UK. Follow him on Twitter at ScienceF1RST. 3. Massive black hole merger detected, gravitational wave discovery. Imagine witnessing the most cataclysmic event in the universe, a collision between two colossal black holes, each more than 100 times the mass of our Sun. But here's where it gets truly fascinating. Scientists have just detected the ripples in spacetime caused by this monumental cosmic dance, marking the largest black hole merger ever recorded. These monstrous black holes, which began orbiting each other eons ago, eventually collided and fused into a single, even more massive black hole located approximately 10 billion light-years away from Earth. The event, captured by gravitational wave detectors on our planet, has sent shockwaves through the physics community, prompting a re-evaluation of existing theories on black hole formation. On November 23, 2023, just before 2 p.m. UK time, the Laser Interferometer Gravitational Wave Observatory, LIGO, operating two detectors in Washington and Louisiana, picked up a simultaneous signal. This signal, representing the final moments of the black hole merger, lasted for only 1/10 of a second. During this brief period, the detectors experienced minute stretching and squeezing movements, tiny ripples in the fabric of spacetime, smaller than the width of a proton. According to Professor Mark Hahn-Nahm, head of the Gravity Exploration Institute at Cardiff University, these are the most violent events we can observe, yet when their signals reach Earth, they are among the weakest phenomena we can measure. Despite their minuscule size upon arrival, these ripples offer invaluable insights into the dynamics of black hole collisions. The analysis of the gravitational wave signal revealed that the merging black holes weighed 103 and 137 solar masses, respectively, and were spinning at an astonishing rate of about 400,000 revolutions per minute, close to the maximum speed theoretically possible for such objects. What's particularly intriguing is that these black holes fall within a mass range where their existence is unexpected due to various astrophysical factors. Typically, black holes form when massive stars exhaust their nuclear fuel and collapse at the end of their life cycles. However, the sheer mass and rapid spin of the recently observed black holes suggest a different origin. Scientists hypothesize that these black holes might be the result of multiple previous mergers, an idea supported by previous observations but never before confirmed on such a grand scale. To date, LIGO has detected around 300 black hole mergers through gravitational waves. Prior to this discovery, the heaviest known merger resulted in a black hole approximately 140 solar masses. In contrast, the latest event produced a black hole weighing up to 265 solar masses, setting a new record. This groundbreaking detection highlights the transformative power of gravitational wave astronomy. Before the advent of gravitational wave detectors in the 1990s, our understanding of the universe was limited to observations of electromagnetic radiation. Gravitational wave observatories now provide a fresh perspective, unveiling phenomena previously hidden from view. Whenever we explore the universe through a new medium, Hahn-Nahm explains, we often uncover unexpected phenomena that reshape our understanding of the cosmos. Future advancements in detector technology promise to reveal even more about the universe's black hole population, potentially leading to further surprises. What do you think? Could there be other explanations for the formation of these massive black holes? Share your thoughts in the comments.